Yay, you came back. Okay, so the general form of a line is something of the form ax plus by equals c, where a and b are not both equal to 0. Maybe one of them is, but not both. It's also called the standard form for a line. Okay. So graph the equation 2x plus 3y equals 6. Notice this is a standard or general form. It's something times x plus something times y equals something, and both of these numbers aren't 0. It's allowed for one of them to be 0 as long as they're not both 0. Okay, so it says graph the equation by finding its intercepts. So remember, to find the x-intercept, let y be 0. So if I let y be 0, that part goes away, and we just have 2x equals 6, and I get x equals 3. So it has the intercept x equals 3, y equals 0. On the other hand, if I let x equal 0, then this part goes away, and I get 3y equals 6, which tells me y equals 2. So 0, 2 is an intercept. So we have the intercepts 0, 2, and 3, 0, which I can just plot. Here's a 0, 2, here's 3, 0, and once I have 2 points, it's pretty easy to draw the line just by connecting them, assuming you can draw better than I can. Okay. What does it mean for lines to be parallel? And don't answer too fast, because some people may have said if they have the same slope. That's true, but it's not the real definition. The real definition of parallel lines is that they do not ever touch each other. They do not intersect. So this line and this line, because they intersect, are not parallel. This line and this line, because they never will intersect, are parallel. Okay. It happens to be true that non-vertical lines are parallel if and only if their slopes are equal. According to the way this book says it, a line is not considered parallel to itself. It has to be a different line. So they have to have the same slope and not be this line, and therefore have different intercepts. Okay. So if two non-vertical lines are parallel, their slopes are equal. If two non-vertical lines have equal slope and they're not the same line because they have different intercepts, then they are parallel. So, are the following two lines parallel? What are their slopes? So we're going to write, sorry, let me put them back up here a little longer. Here's the first line, x plus 2y equals 6. Here's the second line, 2x plus 4y equals 0. Are these parallel? So we're going to put them in slope-intercept form. X plus 2y equals 6, subtract the x, divide by 2, and here is slope-intercept form for the first line. So the slope is -1/2, and the y-intercept is 3, which you can just read off like that. The second line, 2x 4y equals 0, move the x's over and then divide by the 4, and you get y equals -1/2, which is the same as y equals -1/2 x plus what? Okay, so what's the slope? Well, it's still -1/2. What's the intercept? Plus 0. So the slope is -1/2, and the y-intercept is 0. So did these lines have the same slope? They did. Were they the same line? No, because their intercepts were different. So same slope, not the same line, or they are parallel. Okay, and here's a graph of them. They have the same direction. They're never going to intersect. They're parallel. Okay, so can we find an equation of a line that goes through the point 1, 0 and is parallel to the line x plus 2y equals 6? Okay, so here is a line. I don't want this line. I want something parallel to it that goes through this point. Well, the line I'm trying to make has to have the same slope. So let's find the slope of this line. Let's move some stuff around. I move the x over to the other side and divide by the 2, and I get this. So here is this line in slope-intercept form. What's its slope? -1/2. Okay. So now I have a known slope, -1/2. That will make the line parallel to this other one we were given if it has the same slope, -1/2. But I want it to go through this point. So I want a line with slope through this point. I want to use point-slope form. Okay, this is why point-slope form is usually the best way to go, because it's the most flexible form. Anytime you say, oh, I have a point and I have a slope, what's the line? Just use point slope form and you're done. So what's the point? It's 1, 0. So I let x1 be 1 and y1 be 0. What's the slope? It was negative 1/2. So I plug that in right there. Move some stuff around and simplify. There you go. This is our slope-intercept form that most people are going to be comfortable with. If you multiply everything by 2 and throw the x back to the other side, you can put it in its general form, but that's totally optional. To see how that works, starting from here, multiply both sides by 2, you get 2y is equal to 2 times negative 1/2 x 1/2. If I distribute that 2 out, I get negative x plus 1. Now I'm going to take this x and add it to the other side, and that gives me that right there, x plus 2y equals 1. So the line x plus 2y is parallel to the line x plus 2y equals 6 and contains the point 1, 0. That's what we just did. That's parallel lines. What about perpendicular lines? Well, lines are perpendicular when they intersect at right angles. Two lines are perpendicular if the product of the slope is negative 1. And if two lines are perpendicular, then the product of their slope is negative 1. Okay, this is, if you have one condition, you have the other. So, suppose a line has slope minus 1/2. What is the perpendicular slope? Well, if I call that, let's call it S, perpendicular slope, then S times negative 1/2 would have to equal 1. If I divide both sides by negative 1/2, I get S is equal to 1 over negative 1/2, which is negative 1/2, which is 2. So, negative 2, sorry. Oh, I wanted the product to be minus 1, right? I want the product of the two slopes to be minus 1. It's negative 1 over negative 1/2. It's positive 2. So let's find the equation of a line that goes through the point 1, minus 2 and is perpendicular to the line x plus 2y equals 2. I notice we have a point on the line that we're trying to find the equation of. So what's the missing information? If I have a point, what I need is the slope. How am I going to find the slope? It's perpendicular to this one. So let's find the slope of this line right here. Okay, so let's get it into slope-intercept form. Move the x over. 2y equals negative x plus 2. Divide out this 2, and we get negative 1/2 x plus 1. That's not so important for us. What we really care about is that this slope is negative 1/2. So what's the perpendicular slope? Well, we actually just did that work on the other page. It's 2. So since our line has slope minus 1/2, then the perpendicular line will have slope 2. We know our desired line goes through this point and must have slope 2, so we use slope-intercept form and we're done. Honestly, we can stop right here. This I consider to be a perfectly legit equation of a line. It's in point slope form. Something tells me the book is going to expect you most of the time to get slope-intercept, but you can stop for me with point slope form. Okay. So what's the general way to find the equation of a line perpendicular to a given line? Okay, so what we just did is simplify one line into slope-intercept form. Oh, sorry, this is the same example. So here's the equation of the line. It is the green one. Okay, so we were given go through this point, but be perpendicular to this line right here, and we've just determined it's that one. Okay. So in summary, can you compute slopes of lines if you have 2 points? Sure. Rise over run, delta y over delta x, change in y over change in x. And then we have various forms of equations for lines. The most flexible is point slope. There's also slope-intercept, which most people are comfortable and familiar with. Two lines are parallel when they have the same slope, and they're perpendicular if the product of the slope is minus 1.